Okay, today we are going to learn about the properties of inverse trigonometric functions, and we are going to do the related exercises. Okay, so we have already learned what is an inverse trigonometric function, how it is working, and what is the principal value branch, and how we do find the value of any inverse function. Say if I give sine inverse 1 by 2, you understood how you have to find out that time. Okay, so just by understanding all those things, I can tell that sine of sine inverse x or cos of cos inverse x is equal to x, because this is in the inverse functions, right? If they are going to be in the inverse functions, we know that f of f inverse is equal to an identity function. So f of f inverse should be equal to an identity function. But what is the case of this? X should be in the codomain. X should be in the domain of this sine inverse function. What is the domain of that sine inverse function? That we need to mention here. That is very important. We cannot tell every x over there, because x cannot be any real number over there, because you are considering only the sine inverse function. So here you have x is equal to, or x belongs to minus 1 to 1, and here also it is the same, because the cos function can take only these many values, that is from minus 1 to 1. Okay, tan, it will be x belonging to r. If it is sec and cosec and all, x r minus 1 to 1, minus 1 and 1 not included in that. So okay, that is just a case. That is the first type. Second type comes to be sine inverse of sine theta. Let me take it to be some theta, and cos inverse of cos theta. How can I write it to be theta? We know that f inverse dot f also should be an identity function for the domain of the function f. Based on that means that the domain of this function should be the identity. At last you need to get that. So what can I consider to be the domain of these functions? So for sine inverse and cos inverse to be existing properly, I need to check that the sine theta should be lying in the first quadrant or in the fourth quadrant. For that, theta should be belonging to minus pi by 2 to pi by 2. That is the principal value branch. Principal value branch. You found out the difference between these two. Here you are considering only for the sine inverse function, because there is a restriction over there. Sine of any function could be found out very easily, but when you consider this case, you have sine inverse function outside. Sine theta is very easy to find out, because it is based on since you are restricting only to this codomain for this theta function, so theta should be belonging to this domain. Okay, so what you are getting from this sine theta will be the codomain. So that codomain should be belonging to that sine inverse function. But the sine inverse function should have only first and the fourth quadrant. For that, theta should be belonging to minus pi by 2 to pi by 2. That is the theta. So here you have cos function. Cos function should be theta, should be belonging to the first and the second quadrant. For belonging to first and second quadrant, it should be from 0 to pi. Okay, this is the thing we need to know. Based on this, there can be different questions, like I can give an angle which is 2 pi more than this. So maybe I'll take sine inverse sine of 3 pi by 4. 3 pi by 4 is not, I cannot write it directly to be theta, because theta is not belonging to this group. It is greater than 3 pi by 4. I need to get some value for which it is going to be coming in this range. So sine, just by seeing this, I remember of one of these identities, that is sine pi minus theta is equal to sine theta. Sine theta. Sine pi minus theta is equal to sine theta. I'll substitute that thing over here. Okay, so I can equate it to be like this. So it is sine inverse of sine, it becomes pi minus pi by 4, that is pi minus 3 pi by 4. 1 minus 3 by 4 is 1 by 4. This becomes to be sine pi by 4. Therefore, it becomes to be pi by 4. Okay. So just by seeing this, you can make out that it cannot be always equal to theta. It can be equal to different cases based on the value of this. Because when theta is belonging to only this range, only then you will get direct theta itself. If it is not belonging to that range, you are going to get a different, entirely different value in that case. Okay, that's it. Now we are going to the properties of inverse trigonometric functions. Now we are going to learn about the properties of inverse trigonometric functions. So the first set of properties of inverse trigonometric functions come to be the reciprocals. In sin x, we found out that sin x, 1 by sin x was cosec x, 1 by cos x was sec x, and 1 by tan x was cot x. How it is going to come here? We'll just check now. So I can write it as sin inverse 1 by x, cos inverse 1 by x, tan inverse 1 by x. Okay, I'll do one of them and just write similarly on based on that. Okay, so the first one is sin inverse 1 by x, sin inverse 1 by x. That will be, let me take it to be some y is some other variable. So I'll take sine on both sides. So 1 by x is equal to sin y. Taking the reciprocals on both sides, this comes to be x is equal to cosec y. Taking cosec inverse on both sides, cosec inverse x is equal to y. But y was equal to sin inverse 1 by x, and also y is equal to cosec inverse 1 by x. Therefore, it is going to be cosec inverse x. That is the thing. So what should be the domain here? The domain should be that of the cosec inverse function. Cosec inverse function is going to have the domain that is going to be, that is x modulus of x is always greater than or equal to 1. That is the domain for the cosec inverse function, where it is going to be always the value, absolute value of that thing is going to be greater than or equal to 1. That means it can be either positive values or negative values, excluding the numbers between -1 and 1. So okay, similarly this is going to be sec inverse x and coming to the same condition, and this is going to be cot inverse x. Cot inverse x when x is greater than 0. X is greater than 0. Why this condition has come up? Because in these two conditions, in these two cases, you are going to get the same value. I mean, this is going to have the same principal value branch. Even sin inverse and cosec inverse have the same principal value branch. But when you consider the principal value branches of tan inverse and cot inverse function, they are going to be different. They are going to intersect only in the first quadrant. Only in the first quadrant they are going to be intersecting. While the cot inverse function has first and the second, tan inverse function is going to have the in the first and the fourth quadrant. Therefore, their intersection comes to be in the positive. Therefore, when it is greater than 0, that is only in the first quadrant, this thing is going to be applicable. Okay. Next, we'll move on to the second property. Now we are going to have a second set of properties. Second set of properties and the third set belong to the negative of thing. Like sine of -x was the thing that you learnt in trigonometric functions. Here you are going to learn about sine inverse of -x, and you have cosec inverse of -x and tan inverse of -x. I have grouped all these three together because they have the same principal value, similar principal value of branch, with some exceptions like here 0 is not there, here pi by 2 and minus pi by 2 are not present. Leaving this, all those things, I am just taking the other things. So let me take y is equal to sine inverse x. That was a similar method I used. So now I am taking sine on both sides. This comes to be sine y is equal to -x. Taking minus to the left hand side, this comes to be minus sine y is equal to x. Okay, sine of some function minus sine of something, minus sine of y is equal to sine of minus y. That was the thing we learned in last year. Sine of -x was minus sine x. Like that, minus sine y is equal to sine of minus y. So this comes to be sine of minus y. That is equal to x. Taking sine inverse on both sides, you have minus y is equal to sine inverse x, or y is equal to minus sine inverse x, minus sine inverse x. That means I have already told in the previous thing how we were while doing sine inverse of minus half, directly I wrote first minus and then sine inverse 1 by 2, and then I found out the value of this thing, sine inverse 1 by 2. That was the thing I used here. That was the thing that you're going to get here. So you're getting here minus sine inverse x. So similarly it's going to be minus cosec inverse x and minus tan inverse x. Okay. Here always in this inverse trigonometric functions you need to be very careful about the domains. So here x is the belonging to this, where x is belonging to minus pi by 2 to pi by 2. Okay, minus pi by 2 to pi by 2. Here you are going to have x is equal to minus pi by 2 to pi by 2, excluding 0, excluding this at 0. And here the domain of the inverse function, that is x, should be belonging to x should be belonging to what number? It should be always our real numbers, right? Oh, that was the thing, right? It should be real numbers. So I need to consider the numbers here. So it is sine inverse of x. So x has to be in between minus 1 to 1, and here also it should be where modulus value of x, that was the simpler one I used, right? In the previous one also, modulus value of x is greater than or equal to 1. That was the easier one to conclude over there. So that's the thing for that. Okay, this is the third set where I am going to take this cos inverse, sec inverse and cot inverse of negative, that is minus x, and how I'm going to get the things. So this similar way to do, y is equal to cos inverse x, or I can tell x to be cos y. It was minus here, so minus I need to take to the right hand side. So x is minus cos y, minus cos y. Since cos is positive in the first and the fourth quadrant and negative in the, it is negative in the second and the third quadrant, I am going to consider the second quadrant. For reason is because I am considering the cos inverse of that. So I need to better consider the second quadrant. For considering the second quadrant, I need to take it to be pi minus that value, pi minus theta, or x is equal to cos of pi minus y, that is 180 degree minus theta. It is going to be coming to be minus of cos theta. Theta is y here. So taking cos inverse on both sides, pi minus y is equal to cos inverse x. Okay. So now we need to substitute this one here. This comes to be pi minus cos inverse minus x is equal to cos inverse x. We need to get the value of cos inverse of minus x. So just interchange. Come, bring this here, bring this here. So cos inverse minus x is equal to pi minus cos inverse x. So that's the thing. That's it. Pi minus cos inverse x, pi minus sec inverse x, pi minus cot inverse x. All these things are going to be the same because it is similar, right? That's the thing. So next is the fourth set of properties for inverse trigonometric functions. Next you have a fourth set of properties of inverse trigonometric functions where you are going to add the inverse of things. So it is going to be sin inverse x plus cos inverse x and sec inverse x plus cosec inverse x and tan inverse x plus cot inverse x. You are going to find the sum in each case. What is going to be the domain is important here. So x is belonging to, therefore modulus value of x is less than or equal to 1. Here the modulus value of x is greater than or equal to 1. Here x can be any number, any real number, not the complex numbers and all, only real numbers. So how do you need to find the sum of these two? Okay, let me take y. Y is equal to sin inverse x, sin inverse x. Therefore x is equal to sin y. that much we know. So I can consider a sine of something is pi by 2 minus cos of that thing. Sine theta is equal to cos of pi by 2 minus theta, 90 degree minus theta, or pi by 2 minus theta. Therefore it is cos of pi by 2 minus y. Okay, what is x? So okay, let me take cos inverse on both sides. Okay, cos inverse x is equal to pi by 2 minus y. Let me substitute this y is sine inverse x. Therefore cos inverse x is equal to pi by 2 minus sine inverse x. So if I bring this to the left hand side, you are going to get the sum, that is sine inverse x plus cos inverse x is equal to pi by 2. That is the thing, that is the property you are going to get here. So we can substitute, it is going to be pi by 2 in all the cases based on their given domain. Okay, so you need to know that this is based on this property, that is sine theta is equal to cos of pi by 2 minus theta. Next we are going to have a number of things about tan inverse. Now you have the fifth set of properties, that is addition and subtraction involving tan inverse functions. Okay, this is tan inverse x minus tan inverse y, what it will be equal to. So if I am given two terms with tan inverse and I want to get only one term for that tan, what I am going to do? Okay, this is generally many type of questions are solved based on this method. What I am going to do now, so let me take theta to be the first term, that is tan inverse x, and phi to be the second term, that is tan inverse y. Okay, that much is over. Now this next step is you are asked to find the tan of theta plus phi, because at last you need a tan inverse thing, tan inverse inside the bracket. You need to get an expression based on which you are going to calculate tan inverse x plus tan inverse y. So tan of theta plus phi is equal to how much? So just by our method that a formula we learned last year, that is tan of a plus b is equal to tan a plus tan b, tan a plus tan b. Tan of a plus b is equal to, let me write that here, tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a tan b. Okay, that is the thing which directly we are going to use that. So you have, that is tan of a is the first, that is theta, tan theta plus tan phi divided by 1 minus tan theta tan phi. Okay, so if I take tan theta, it becomes x, right? This is going to be x. Tan of tan inverse x, you are going to get, that is x itself. Similarly you are going to get y, and 1 minus xy, x into y. That is the thing you are going to get. Therefore this expression becomes x plus y into 1 minus xy. What is the condition? That's very important here. Many of the questions are just based on that condition. If that condition is not satisfied, you are going to use a different method that I am going to tell you later. So this is going to be tan inverse, because tan of theta plus phi is this much, right? Therefore theta plus phi comes to be tan inverse of this thing. So it is going to be tan inverse of x plus y divided by 1 minus xy. So in the next case I'm just going to substitute one minus sign here. So you are going to get x minus y by 1 plus xy if it is a negative sign in between. So at last you are going to get tan inverse x minus y divided by 1 plus xy. What is the condition? Condition is very important here. So I need to explain why the condition has arisen. I'll just rub this off. For that, we know that tan inverse 1 is pi by 4. Tan inverse 1 is pi by 4, right? Tan inverse 1 is equal to pi by 4. That is the thing. Therefore the angle pi by 4 comes to be here. I'm just drawing, okay, rough thing. This is pi by 4. And if I'm going to add two numbers, x plus y, if it is, the condition comes to be xy should be always less than 1. That is, the product of the two terms should be always less than 1. So if I consider one example, when you are given a condition, you need to always think in opposite direction. So here you are given xy is less than 1. What will happen is if xy is greater than 1, okay? If xy is greater than 1, what you are going to get? So say, let me have tan inverse 2 and tan inverse 3, okay? So this is greater than tan inverse 1 or greater than pi by 4, and this is also greater than pi by 4. Okay, if I substitute this here, it is going to be tan inverse of 2 plus 3 divided by 1 minus 6. That is going to be tan inverse 5 by minus 5. That is going to be minus pi by 4. But if I add these two, I need to get something that is greater than pi by 2. Right? It is greater than pi by 2. But when I got this, I got minus pi by 4. Why has this come? Because it is going to cross this pi by 4 line. If you take two terms that are coming in this range, if you add those two terms, it will cross this range and it will go to some other range. In such a case, to maintain that tan inverse, the domain of that tan inverse, it has to be coming under this first or the fourth quadrant only. So it changes to minus pi by 4 instead of 3 pi by 4. Got it? It has to be 3 pi by 4 when you add this, but you got it to be minus pi by 4. Therefore, you cannot take it in that condition. Okay? Similarly, you need to also have xy is greater than minus 1 in this case. Okay? There is just this opposite of that. Because you are considering multiply minus 1 on both sides. Okay? What you are going to get? This inequality is going to change when I am going to multiply by minus 1. So it is going to be like that. Now the sixth property of the properties of inverse trigonometric functions is about 2 tan inverse x. We are given three things. I will just go on writing and just prove the right hand side is equal to the left hand side. So the first thing is tan inverse of 2x by 1 minus x square when x square or x is always less than 1. Okay, modulus value of x is always less than 1. So because it is x square, I can take modulus value of x is always. Now we have an example 3. The second part of that, you need to show that sine inverse of 2x by root of 1 minus x square is equal to 2 cos inverse x, and this condition, that is x is in between 1 by root 2 and 1. So it is how it is going to be now. So in the first part of the question, we had to substitute either to be sin x or cos x. Just by seeing this, I can understand that it is coming to be sin 2 theta form, that is 2 sin theta cos theta. Okay, but you have two options. X can be either sin theta, x can be either cos theta. Two options are there. So I need to think. For that, this option, this is given. Yes, so we need to substitute based on that. So what is going to be cos theta in both the cases? We need to check whether the cos inverse of that thing is coming to be in the principal value branch of the given thing. So if you have cos inverse x, here x was given to be in between 1 by root 2 and 1. Okay, now what will be cos inverse x in between? For that you need to substitute cos inverse 1 by root 2, that is pi by 4, and what you are going to get here is 0. That is between pi by 4 and 0. So I'll check for sine inverse, which will work better. Sine inverse x is in between. So sine inverse 1 by root 2 comes to be pi by 4 in both same, and this is pi by 2. But in the right hand side you are going to multiply it by 2, and the sine inverse function should be in between, always in between that thing. Okay, so we need to think of the right hand side. Always you know that sine inverse function should land up in between the first or the fourth quadrant. But in this case you have 2 cos inverse x in the right hand side. Therefore it is going to be better to take cos inverse x. Okay, I'll explain once more while substituting. So this much we found out here. So what you found out here is sine inverse, that is left hand side, is equal to sine inverse of 2 cos theta root of 1 minus x square is root of 1 minus cos square x. Okay, I'm going to substitute cos inverse x is equal to theta. In this case, that was the substitution I had required. So when I substitute x to be cos theta, or cos inverse x to be theta, this becomes cos theta into root of 1 minus cos square theta. 1 minus cos square theta is sin theta. Root of that comes to be sin theta. That was simple. So now we're going to be 2 into cos theta into sin theta. That was this thing. So it is coming to be sin inverse of sin 2 theta. Okay. So we need to understand that this 2 theta, in the first part we found out, first thing of today's class, that was sine inverse of sin x. Therefore it should be belonging to it should be an angle that is belonging to the principal value branch, because it is a sine function. So it should be always in between minus pi by 2 to pi by 2. Okay, and I'll take 2 on both sides. This comes to be minus pi by 4 to pi by 4. Okay, from in this case we found out that substitution, that is theta here, cos inverse x was in between pi by 4 and 0. That was okay for this. But if I take sine inverse x to be theta, it is going to be in between pi by 4 and pi by 2. That is not coming out in this case. It is going out of that. Therefore this substitution would become wrong in that case. Therefore this is the better substitution. So it comes to be 2 into theta, sine inverse of sine. So what is theta here? Theta was cos inverse x. This is 2 cos inverse x. That was the substitution. This comes to be the right hand side, hence proved. I hope you understood how the condition has arisen. So when I substituted cos theta here, I got the same sin 2 theta form. If I had substituted sin theta, again we are getting the sin 2 theta form. But while using that thing, we have to be careful. It could be 2 theta, and that 2 theta should be in the principal value branch. That is, it should be in between minus pi by 2 to pi by 2, because it is the sine inverse function. So what you are going to get here is that substitution, that is theta, should be in between minus pi by 4 and pi by 4. But when we considered this sine inverse x case, it came to be pi by 4 to pi by 2. That was greater. Therefore that substitution will not work out, and this has to be used in that case. We cannot use sine inverse. That's what we understood from this case. Okay, moving to the next example. Now you have the example 5. You are asked to simplify the given expression, that is tan inverse of cos x divided by 1 minus sin x, and there's a given condition. Okay, maybe there is going to be some use from that condition at the last. So you have now tan inverse. So inside you need to get some form of tan function. So you need to get tan of something, so that I can just simplify and write that. For that I need to get sin 2 theta and 1 minus cos theta are more simplifiable. Sin theta, okay, sin theta is equal to 2 sin theta by 2 cos theta by 2, and 1 minus cos theta is equal to 2 sin square theta by 2 are the things that can be substituted. But you have cos x and 1 minus sin x. So for that I am going to subtract it from pi by 2. So it comes to be cos. Now cos of something, you can write it to be sine of that thing, that is sine of pi by 2 minus x, and you have 1 minus cos of pi by 2 minus x. So this now it becomes sin theta and 1 minus cos theta. I can substitute those forms. So now it becomes tan inverse of 2 sine of theta by 2 is pi by 4 minus x by 2 cos of pi by 4 minus x by 2 divided by 2 sine square of pi by 4 minus x by 2. Okay, now we'll cancel this off. So now what you're going to get is, here also one more sign can be cancelled. This becomes cot or tan inverse of cot pi by 4 minus x by 2. Okay, these many things I have used now. This thing, these two things I have already used. I'll rub this off. I need to use one more identity at the last. What is this identity? So cot theta is equal to tan of pi by 2 minus theta. That is the same thing you're going to get here. So you get it, tan inverse of tan pi by 2 minus pi by 4 plus x by 2. Because it is going to be minus of minus x by 2, you get plus x by 2. So here you have pi by 2 minus pi by 4, that is tan inverse and tan is going to get cancelled, only the remaining this thing comes, that is x by 2 plus pi by 4 is the answer. This is the answer, x by 2 plus pi by 4, that is simplified answer for the given question. So why has this come here? So it had to be, this was pi by 4 plus x by 2. Somehow I need to get this from here. Now have x in between minus 3 pi by 2 and 3 pi by 2. I'll divide by 2, this comes to be 4 and this also comes to be 4. I'll add pi by 4 on both the sides. So if I add pi by 4 on both sides, this becomes minus pi by 2 and this becomes pi by 2 as I added. So this is going to coming in the tan inverse, that is the principal value branch of the tan inverse function. Okay. Example 6. Simplify cot inverse 1 by root of x square minus 1 and x is given to be greater than 1. So you are asked to simplify this statement. So you are getting so many big things. So inside the square root you need to get a square number. So generally we know that sec square x minus 1 is equal to tan square x and cosec square x minus 1 is equal to cot square x. Okay, these two things I know. Based on this I need to check which is going to work here. Okay, so first we'll substitute maybe sec square only, that is a better option. At the last we'll find out why it is a better option. So we'll substitute, let it be theta. X is equal to c theta. So what does this become? Cot inverse 1 by root of x square minus 1 becomes cot inverse 1 by root of sec square theta minus 1. Sec square theta minus 1 is equal to tan square theta. So this becomes cot inverse 1 by tan square theta and one root. So root and that square cancels off. So you have cot inverse 1 by tan theta, that is equal to cot inverse cot theta. Okay, cot inverse cot theta. So what is the condition at last for that, such that this should be lying in between 0 and pi. Theta should be belonging from 0 to pi. So what should be the condition? Sec theta stands for sec inverse x. So sec inverse x should be belonging to 0 to pi. So let us take this condition and explain this. So x is greater than 1. What happens to sec inverse x? Sec inverse x. So taking sec inverse x on both sides, what you are going to get is sec inverse x is greater than sec inverse 1. Sec inverse 1 is 0. Therefore sec inverse x is greater than 0. Okay, so by this one you get is equal to theta. Theta stands for sec inverse x. Okay, what will happen if you are going to take cosec square? First of all, you are not going to get this term, and also we'll see how the statement comes to be. So cosec inverse x should be greater than cosec inverse 1. Cosec inverse x is therefore should be greater than 1 stands for when sin theta is also 1. When sin theta is 1, theta is equal to pi by 2 or 90 degree. But therefore cosec inverse cannot be more than 90 degree. Also, therefore that cannot be the substitution in this case. Okay. Now we have the exercise 2.2. The first and the second question I have written here. They two are similar. Okay. For this you need the substitution method that I used in the proving that tan inverse things. So here what you are going to get is, let us take the right hand side and then prove this. This comes to be sine inverse 3x minus 4x cube. Now we need a substitution for x such that you get the left hand side. So let us substitute, let x is equal to sine theta. Let x is equal to sine theta. Therefore the RHS becomes sine inverse 3 sine theta minus 4 sine cube theta. So what does it form? This is the form for sine 3 theta that you have learnt last year already. Therefore this is sine 3 theta. Sine inverse of sine 3 theta comes to be 3 theta. So what is theta here? Theta is sine inverse x. That is the LHS. So why has this come over here? Since x is belonging to minus half to half, sine inverse sine, that means that sine theta is belonging to half minus half to half. Okay, let me take sine inverse on all the sides. So sine inverse of minus half comes to be pi by 6 minus pi by 6, and it is equal to theta less than or equal to pi by 6, or 3 theta should be in between minus pi by 2 and pi by 2. Since this case satisfies, that is 3 theta is belonging to minus pi by 2 to pi by 2, you can write 3 theta directly from here. That's why you can write it over there. Okay. Next is the second case. Here it is the same thing. So we are going to take the right hand side. This becomes cos inverse 4. Let x is equal to cos theta. Let x is equal to cos theta. There is a substitution here. So this comes to be 4 cos cube theta minus 3 cos theta. This is the same form for cos 3 theta. So this comes to be cos inverse cos 3 theta, that is 3 theta. So it is theta here is cos inverse x. Therefore this is 3 cos inverse x. Okay. Now why I have taken that cos inverse x, and how does this step arise? Okay, that is the point. Similar to this, since x is belonging to half to 1, cos theta is belonging to half to 1. Okay, let's take cos inverse on both the sides. Then theta comes to be cos inverse half is pi by 3. Okay, then you have cos inverse 1, that is 0. Cos inverse 1 is 0. So similar to this, because this is 3 theta inside, so 3 theta should be belonging to, multiplying 3 on both sides, this comes to be from pi to 0. Okay. Oh, it should be going to the opposite side in this case. That was a mistake. That's why it is coming over there. So this has to be like pi greater than or equal to 3 theta greater than or equal to 0. That is that 3 theta is belonging to what? 0 to pi. That is the principal value branch for the cos inverse function. Okay, we'll move on to the third question. What is the third question? Third question is a direct one, and again it is a prove that question. Since it is a prove that question, you can choose any of the sides. So the question is here, tan inverse 2 by 11 plus tan inverse 7 by 24 should be equal to tan inverse half. That is the question number 3. Okay, we are asked to prove. So this is a more complex, and we can simplify that to the right hand side. So I am going to take to the left hand side. So this comes to be tan inverse 2 by 11 plus tan inverse 7 by 24. So this is tan inverse x plus tan inverse y form. That comes to be tan inverse of x plus y divided by 1 minus x into y. So this is just about simplification. At last you need to get half in this place. So what are you going to get here? Okay, rather than simplifying, just easy ways. Tan inverse, multiply this by this. 2 into 24 comes to be 48, and you have 11 into 7, that is 77. Leave out the denominator, nothing about that, LCM, right? So here 24 into 11 comes to be 264. This is the way you multiply. Because it is 11, it is going to repeat again, doing 1 digits. So it is going to come 24, you get 264. So this is 264 minus 2 into 7 is 14. Okay, now you have 48 plus 77. 7 plus 4 is 11. Okay, let's take tan inverse. Tan inverse, this is 0. 6 minus 1 is 5. This is 250. 7 plus 5 is 15. 1 is carried. 7 plus 4 is 11. 12. 125. That comes to be half. Tan inverse half. That is the right hand side. Hence we have proved. We have taken x plus y. So note that here x into y is less than 1. That is 2 by 11 into 7 by 24 is less than 1. And only in such a case we have taken this. Okay. Now we'll go to the fourth question. Fourth question is similar to the third question, wherein you are going to use the same forms, that is the tan inverse x plus tan inverse y form. So you have the question to be tan inverse half plus tan inverse 1 by 7 is equal to tan inverse 31 divided by 17. Okay. So what you are going to do? So let me take this to the right hand side. So maybe 2 tan inverse. First I'll calculate 2 tan inverse half, and later I'll calculate tan inverse 31 by 17 minus tan inverse 1 by 7. Okay. So what you are going to get here? 2 tan inverse x is tan inverse 2x, 2 into half divided by 1 minus x square. X square is 1 by 2 square, that is 1 by 4. Therefore this comes to be tan inverse 2 into this is 1 in numerator, this is 3 by 4. Okay, now 4 goes to the numerator, this becomes tan inverse 4 by 3. This much I got. This is one part. Another part is I need to do this. So this is tan inverse of x minus y, x, that is 31 by 17 minus 1 by 7 divided by 1 plus 31 by 17 into 1 by 7. At last, however, I need to get this, but we'll simplify. This comes to be tan inverse 31 into 7, 31 into 7, 721, 217 minus 17 divided by 17 into 7, 17 into 7, 7 7s are 49, 7 1s is 7, 119. It comes to be 119 plus 31. So somehow you need to get 4 by 3 here. So this is tan inverse. This is 200, and what you get here is 150. 150. 0 and 0 cancel. 20 by 15 is 4 by 3. 4 by 3. Therefore, 2 tan inverse half is equal to tan inverse 31 by 17 minus tan inverse 1 by 7. Now I'll bring this to the left hand side. That is 2 tan inverse half plus tan inverse 1 by 7 is equal to tan inverse 31 by 17. This is what we had to prove. Okay. Next part of the questions is the making the simplified form. Always for making the simplification, you need to always do the substitution. The substitution method is the easiest rather than going on simplifying using some big calculations and all. Okay. Now you have the fifth question. The fifth question is tan inverse root of 1 plus x square minus 1 divided by x. So I need to think what it is going to be. Here it is given x cannot be equal to 0. If x cannot be equal to 0, so you have a 1 plus x square form. So I can now remember about 1 plus tan square theta and 1 plus cot square theta. This is sec square theta and this is cosec square theta. So the better one was tan square because this is tan inverse here, right? So I'll substitute. Let x is equal to tan theta. What it is going to be? This becomes tan inverse root of 1 plus tan square theta minus 1 divided by tan theta. So okay. So this becomes sec square theta, right? Tan inverse into sec square theta. Root of that becomes sec theta minus 1 divided by tan theta. For simplification, for me sin and cos is very easy and I know how to do that instead of making the sec and all. Okay, so better I'll make that. So this becomes tan inverse. This is 1 by cos x cos theta minus 1 divided by sin theta divided by cos theta. So okay, by simplification you can find out this tan inverse 1 minus cos theta divided by sin theta, because this cos theta you are multiplying to this 1 and the denominators, both the denominators cos theta get cancelled. So this becomes 1 minus cos x divided by sin x. So now the thing is we need to do tan inverse 1 minus cos x stands for 2 sin square theta by 2. 2 sin square theta by 2. This is 2 sin theta by 2 cos theta by 2. 2 and 2 cancel, sin and sin cancel. You get tan inverse tan theta by 2. Okay, therefore this comes to be theta by 2 as the answer. Theta by 2 is the simplified form of this given big things. So what is theta now? Theta is tan inverse x. So this comes to be half tan inverse x is the simplified form. Okay. This is sin theta. This is what we had substituted to be tan theta, and for simplification it is easier to go with this. That's why I am taking this. So later just by applying 1 minus cos theta, 1 minus cos theta is equal to 2 sin square theta by 2. So then I'm substituting this. So sin 2 theta form I wrote 2 sin theta cos theta. Here it was theta by 2. So you got this form. At last you are getting the theta by 2. Then theta you are going to substitute to be tan inverse x. Okay. Next you have the sixth question. Sixth question is again the tan inverse. Many times it comes to be tan inverse only. Okay. Now you have tan inverse 1 by root of x square minus 1, and the condition given is modulus value of x is always greater than 1. So since the modulus value of x is always greater than 1, I can think that it can be sec theta or cos theta, similar to that. So this comes to be For substitution I need to take, since it is tan theta and I know 1 plus tan square theta is equal to sec square theta, taking that form I'll take x to be sec theta. Okay, so what does this form becomes? This becomes tan inverse 1 by root of sec square theta minus 1, that is equal to tan inverse. So sec square theta minus 1 is tan square theta, so you have one root, so this becomes 1 by tan theta. Does it work out? No, this is not going to work out. That's what. So many times it becomes wrong when you just go on doing with this tan inverse, got it? So it's better to take cosec theta so that it is directly, I can do that. So what are you going to get here? This comes to be tan inverse root of cosec square theta minus 1. So what is going to be? This is tan inverse of 1 by cot theta. Similar to this, cosec square theta minus 1 comes to be cot square theta. So root of that comes to be cot theta. So 1 by cot theta is tan theta. So tan inverse tan theta. So what is theta? Theta was cosec inverse x. Theta was cosec inverse x. So that was the form that was required. Okay. So in simple, if you just draw a triangle, say an angle, here I am going to take the angle to be A. The tan of that angle is 1 by root of x square minus 1. Okay. So what will be x? It will be simple form. So this comes to be x, because if you square this, 1 plus x square minus 1. By Pythagoras theorem, the square of this 1 square plus root of x square minus 1. So 1 and 1 is going to be cancelled, and you need to get the root right. So it is root of x square, that comes to be x. So hypotenuse comes to be x. So you can make out that the cosec of that angle is equal to x. That is the simplest form. Or I can tell sine of that angle is equal to 1 by x. Opposite divided by hypotenuse. That is a simpler way, but all the times you don't get that. It is better to go with the substitution method only rather than going with big triangles, and lot of algebra is involved over there. Now we have 7th question. The 7th question is all about again tan inverse. Tan inverse. But here substitution is not required because it is already given to be root of 1 plus 1 minus cos x. 1 minus cos x divided by 1 plus cos x when x is in between 0 and 5. Okay, here it is given to be 1 minus cos x. It should be in between these two. Okay, so I know that 1 minus cos x and 1 plus cos x forms. So directly I can write it to be root of 2 sine square x by 2 and 2 cos square x by 2. You can cancel this off. Okay, if you cancel that off, what you are going to get here is tan inverse sine theta divided by sine x by 2 divided by cos x by 2 comes to be tan, here tan square x by 2 you have one root, therefore it becomes tan x by 2. Okay, therefore it is going to be tan inverse. So the tan inverse is already gone, right? Tan inverse tan. So you get x by 2 is the answer. So x by 2 should be belonging to 0 and pi by 2. Therefore only the first quadrant is considered in this case. First quadrant is only considered in this case. Okay. Moving on to the 8th one. Again it is given about only tan. Here it is cos x minus sin x divided by cos x plus sin x, and the condition is again the same. So since the condition and everything almost looks the same, maybe it is going to be the same. Okay, so better I am going to divide it by cos x and get a tan terms so that it's for me easy. So this comes to be tan inverse of cos inverse, I'm going to divide cos inverse x by dividing by cos x in numerator and denominator. Okay, so this comes to be cos x divided by cos x is 1, and minus sin x by cos x is tan x, and you have cos x divided by cos x is 1, again you get tan x. So this is an important form. Many times it comes to be in the calculus, you get this form and you don't know what to do again. So here what it comes is tan of pi by 4 plus x. Okay, you got it now, tan of pi by 4 plus x. So what you're going to do is you need to expand this. This comes to be tan pi by 4 plus tan x divided by 1 minus tan pi by 4 into tan x. So what you are going to get, you are going to substitute tan pi by 4 to be 1. So this comes to be 1 plus tan x divided by 1 minus tan x. So here only the signs have interchanged. That's why it is going to come to be the negative sign, that is pi by 4 minus x. Therefore this comes to be tan inverse tan of pi by 4 minus x. Okay, therefore the angle is pi by 4 minus x. That is the simplified form of that. Okay, next we'll move to the ninth question. This was the 8th question, right? I didn't even write that. Okay, this is the next is the 9th question. Again it is tan inverse of 4. Tan inverse is not leaving also. Now we have the tan inverse with some extra terms like a, from where that a has come. Here you have x by root of a square minus x square, and the condition is modulus value of x is less than a. Modulus value of x is less than a. What is going to come? So seeing this form, I can tell that it is going to be similar to sine and cos, because in that case you are going to get modulus value of x is less than or equal to 1. So maybe an equal to sign has missed from somewhere, or it is some exception or in this condition. So let me substitute something. So let x is equal to a. So I can bring this a to the downside denominator, and I can tell it to be modulus value of x divided by a is less than 1. Or I am going to substitute x by a to be sin x or cos x. So better I'll substitute to be sin x, because I'll get numerator, I'll get sin x, and here I'll get cos x. So I'll take sin theta here, sin theta, or this is same as x is equal to a sin theta. This thing I'm going to substitute, so this becomes tan inverse a sin theta divided by root of a square minus a square cos square theta. Okay, this is now a sin theta divide, okay, tan inverse is there. So where the tan inverse has come, now it is a sin theta divided by a square is common. If I take a square to be common, out of the root sign a comes out, and what remains is 1 minus, okay, it was sine square, right? Why I have written cos square here? Sine square theta. So 1 minus sine square theta. A and a is going to get cancelled. So you're going to get tan inverse sine theta divided by cos theta. That is root of sine square 1 minus sine square theta. That is tan inverse tan theta. What is theta now? Theta was sine inverse x by a. Sine inverse x by a. Okay, this is the required term. Now we have the 10th one. 10th one is again with the tan inverse thing. So you have some complex terms in that, so many big terms you have. What is the question is 3a square x minus x cube divided by a cube minus 3ax square. Okay, 3a square x minus x cube minus 3ax square. This is the 10th question. Okay, what has come in this 10th question? So similar to this, I can find out tan 3 theta form. Tan 3 theta is equal to 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Somehow I need to get this value. So what was the condition here? The condition is that x should be belonging to minus a by root 3 to a by root 3. Minus a by root 3 to a by root 3. Okay, let it be something. We leave that. So every time we can't go on checking with that. Many times without that seeing itself you can make out. So now whatever is here, x by a we need to substitute like the previous one. So let x by a should be equal to tan theta, or x is equal to a tan theta. So what does the substitution come up here? This comes to be tan inverse of 3a square into a tan theta minus a cube tan cube theta divided by, you have a cube minus 3a into a square tan square theta. Okay, here you have a cube, a square into a, 1 cube, a cube, a cube. Everywhere you can go on cancelling that a cube terms. So what you are going to get here is tan inverse 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. That turns up to be this form. Therefore it comes to be tan inverse tan 3 theta, that is equal to 3 theta, or 3 into tan inverse x by a. Okay, you have the 11th to 14th question I have written here. You are asked to find the values of these in the first 11th and the 12th one. So this is all direct, just going on substituting that. That was similar to the previous one, but it was only one was given. Here so many are given, one after another. So you are asked to find tan inverse of 2 cos inverse of 2 into sin inverse half is 30 degree. 30 degrees pi by 6. So what is pi by 6? This was cos, right? Not cos inverse. 2 pi by 6. So when it get cancelled, you get pi by 3. Okay. So now we have tan inverse of 2 cos pi by 3. Pi by 3 is cos pi by 3 is half. Therefore this becomes tan inverse of 2 into half, or tan inverse 1, that is pi by 4. Okay. Now you have the 12th question, cot of tan inverse a plus cot inverse a. So just by our things we know that cot inverse x plus tan inverse x is equal to pi by 2. Okay, here a is some positive integer only we can consider. So this is going to be cot pi by 2. Cot pi by 2 is 0. Okay, that is the thing. Here you have the 13th question. 13th question, so many conditions are given. It is simple, but it is given so good things. So you can make out the tan of half of sin inverse 2x by 1 plus x square plus cos inverse 1 minus y square plus 1 plus y square. So now we'll consider this part. So let it be like that only. Tan inverse, not tan inverse, tan itself, tan of half. So we know the form, which was the form sin inverse 2x by 1 plus x square. When modulus value of x is less than 1, it comes to be 2 tan inverse x. Okay, now you have this one, cos inverse 1 minus y square divided by 1 plus y square comes to be 2 tan inverse y when y is greater than 0. That is the condition given over there. there it was x given, x was greater than 0. So whenever that variable is positive, that thing, that is 1 minus y square by 1 plus y square, cos inverse of that turns up to be 2 tan inverse of that. Okay, now this 2 and this 2 I'll take it out. This comes to be tan of half into 2 tan inverse x plus y divided by 1 minus xy. How did I get this? If I take 2 outside, the thing that will remain is tan inverse x plus tan inverse y. Tan inverse x plus tan inverse y was tan inverse x plus y divided by 1 minus xy. Half and 2 is going to get cancelled. Now you are going to get tan of tan inverse x plus y divided by 1 minus xy. That is going to be the answer. X plus y divided by 1 minus xy. It is simplified form. Okay, the 14th question given here is the statement sine inverse 1 by 5 plus cos inverse x is equal to 1. Okay, you are asked to find the value of x. So applying sine inverse on both the sides, what you are going to get is sine inverse 1 by 5 plus cos inverse x is equal to sine inverse 1. What is sine inverse 1? Sine inverse 1 is pi by 2. Sine inverse something plus cos inverse something is equal to pi by 2. That means that these two angles are equal. We knew that sine inverse x plus cos inverse x is equal to pi by 2. Okay. Therefore, these two angles have to be same in this case also, because their sum is pi by 2. Therefore, you can substitute, we can just tell that x is equal to 1 by 5. Or by doing big methods, I can explain once more using that method. So let me take this cos inverse to the right hand side. It comes to be sine inverse 1 by 5 is equal to pi by 2 minus cos inverse x, that is equal to sine inverse x, sine inverse 1 by 5. Sine inverse I can cancel, so x is equal to 1 by 5. Okay, that was simple. Moving on to the next type of questions, where you are asked to find the sine of sine inverse of sine, cot of cot inverse, and such things. Okay, you have the 16th and the remaining questions here. So the first one of that is sine inverse of sine 2 pi by 3. So we can find out that 2 pi by 3 doesn't belong to that angles, that is minus pi by 2 to pi by 2, that was the principal value branch of that. So it doesn't belong to that, it is greater than that. So somehow I need to change that value. So the most required one is sine of pi minus theta is equal to sine theta. Okay, sine of pi minus theta is equal to sine theta. When it goes to cos, it becomes minus cos theta, but here it is plus sine theta itself. So this comes to be sine inverse of sine pi minus 2 pi by 3. Pi minus 2 pi by 3 stands for sine inverse of sine pi by 3. Since pi by 3 is belonging to minus pi by 2 to pi by 2, I can write it to be pi by 3. Okay. Now we have tan inverse tan 3 pi by 4. I think I've shown already. I'll do that fast. So similarly, I'm going to use that. This becomes tan inverse tan pi minus 3 pi by 4. That is coming to be tan inverse of tan pi by 4. That is equal to pi by 4. That's what I got. I had also shown in the starting of this class. Okay. Now we have the remaining things. Here it is tan of sine inverse 3 by 5 plus cot inverse 3 by 2. I only know the identities for tan inverse x plus tan inverse y. Okay. So but I have here sine inverse and cot inverse and so many things like this. So but then I'll convert this into tan inverse. That's an easier one, I think. Yeah. So let it be tan of tan inverse of something, and this is tan inverse of 2 by 3. Because it is positive, I can write it to be the reciprocal of that. Okay. Now we have one triangle. one triangle, say this is the angle x, and you have the opposite in sine is opposite divided by the hypotenuse. So this is the common Pythagorean triplet, that is 3, 4, 5. So from this you can find out that the tan of this angle comes to be 3 by 4. Okay, now we have tan A plus tan inverse x plus tan inverse y. So that comes to be tan of tan inverse A plus B, that is 3 by 4 plus 2 by 3 divided by 1 minus 3 by 4 into 2 by 3. Okay, this much we got. Now the remaining part is just about simplification, how fast you can do. So 3 into 3 is 9, 4 into 2 is 8, 9 plus 8. Now we have 4 into 3, 12. 12 minus 3 into 2 is 6. So you have tan of tan inverse 9 plus 8 is 17. 17 divided by number you are going to get is 6 here. 17 divided by 6. So the answer is 17 by 6. Okay. The next remaining part of this questions is about the multiple choice questions. Multiple choice questions are simply based on these types. So what you're going to get here is, now we have the 19th question. So similarly I'll write here itself. We have the 19th question. The 19th question is cos inverse cos 7 pi by 6. Cos inverse cos 7 pi by 6. And okay, remaining things we'll do later. So cos inverse of cos 7 pi by 6. So 7 pi by 6 can be written as pi plus pi by 6. Pi plus pi by 6. So this is pi plus pi by 6. So what will be cos of pi plus theta? Since it is going to the third quadrant, we are going to get a negative sign. Since it is pi, I am getting cos theta itself. Okay. So now what you are going to get here, this is going to be cos inverse of minus cos, since this is 7 pi by 6, I can write it in this form. I am getting the form of cos of pi plus pi by 6, cos of pi plus theta form. At last I am landing up at minus cos theta. Theta is pi by 6. Okay. So now what you are going to get, cos of minus x is pi minus cos inverse of minus x is pi minus cos inverse of that thing. Okay, that is the thing I have used here. Cos inverse of minus x is equal to pi minus cos inverse x. That is the thing I have used. So this comes to be pi minus pi by 6, that is 5 pi by 6. 5 pi by 6 comes to be the option B. Now we have the 20th, and one more question is there, no? We have sine of pi by 3 minus sine inverse half. Sine of pi by 3 minus sine inverse minus half. Sine inverse minus half, that is a simple thing you got. So minus of minus I can cancel. So okay, let it be, I'll write big one step. One more sine of pi by 3. Minus of minus is plus. Sine inverse half is pi by 6. So this comes to be sine of pi by 2, that is 1. 1 comes to be the option D. So now you have the 21st question. 21st question is about tan inverse root 3 minus cot inverse minus root 3. So seeing this, you may get a tendency of cancelling this minus and this minus. But that is not the case here, because there is a cot inverse that has the principal value branch at 0 to pi. And it doesn't have the negative values, hence you cannot cancel that minuses. So tan inverse root 3 comes to be, it is 60 degree. 60 degree is pi by 3. The cot of some negative angle. Okay, I'll try to find that angle, easier way. minus pi by 3, so it is going to come here. Cot of pi minus theta is equal to minus cot theta. Therefore, theta, since it is root 3, it is going to be at 30 degree. Therefore, it is pi by 6. So this comes to be at pi minus pi by 6. Pi minus pi by 6. Okay, what is going to be pi by 3 plus pi by 6 minus pi. Pi by 3 plus pi by 6 is pi by 2. Pi by 2 minus pi comes to be minus pi by 2. Minus pi by 2 lands with the option B. Okay, thank you for today. Next class we are going to learn about the miscellaneous examples and miscellaneous exercise that involve a different type of questions than this easy questions. Okay, thank you. Okay, you have the 17th question, that is tan inverse of tan 3 pi by 4. How you are going to do? You have it in the second quadrant. Second quadrant, tan is negative, so we need to search out of the first and the fourth quadrant you have as a principal branches. So this is negative and fourth quadrant is also negative. Therefore, you need to get an angle that is present in this fourth quadrant. So we know that the function of tan is periodic with the period of pi. So tan of pi plus theta is equal to tan theta. Okay. Now let pi plus theta be equal to 3 pi by 4. Therefore, that angle becomes 3 pi by 4 minus pi, that is minus pi by 4. Therefore, I can write it to be tan inverse of tan minus pi by 4, or I can write it to be minus pi by 4. Okay, this is it. Moving on to the 18th question.